All right, hello everyone. Thanks for coming. My name is Jimmy Bogard. You can still find me on Twitter/X, formerly known as whatever, while it's still up, I guess, at @jbogard. And this presentation, as well as the code, is on my GitHub at github.com/jbogard. And then I blog about this and other topics on my blog at jimmybogard.com. So this talk it comes from, like most of my talks, it's coming from a client experience. And this is basically about 12 months of my life at one point, migrating an existing .NET 4.8 application, an ASP.NET MVC 5 something, over to, at the time it was .NET 6 and now has been migrated to .NET 8. There's not a whole lot of things that have changed from like .NET 6, .NET 8, but when they come up with those things, I'll make sure and highlight them. So like any kind of migration, I try not to have the migration being kind of a big bang all at once sort of deployment. Ideally what we can do is incrementally migrate an application from like the old state to the new state and then be able to deploy those changes out to production as we go. And so this actually reminds me a lot of how we build highways in Texas, which is like all the time we're building highways. And so when we're looking at some kind of like, okay, we have an existing road here and we need to upgrade it to a nicer, newer road. What they don't do is like build a completely new road to the side and just like this pristine greenfield conditions. And then one day, like 5 years into construction, it's done and then just like flip the switch and everyone goes and uses the new road. That's not how they do things. Instead, it's a very incremental process where they'll do sections of the road one at a time. And during those periods of like two roads, like one is new and one is old, like there'll be some bumpy transitions from one to the next. And so we'll see the similar kind of thing in our migration as well. In order to avoid a really risky big bang, hope it all works, flip the switch sort of deployment, and instead we're going to be doing a very incremental migration. But during that migration, things may not look super clean or great, but the idea is that by the end, we'll have a nice new system we're working with, and then we'll have to remove all those shims and whatnot over the time there. So this was the picture that we looked at coming into .NET. So this is the .NET versions that have existed over time. So this application that I was working with actually got started like somewhere around here, 2008, 2009. And was on some .NET framework, either 3.5 or soon was upgraded to .NET 4.0. And it was continuously built and improved over time. So new features were being added all the way up until when we started the project, which is around right here, about 2022, 2023 here. So it had like 15 years or so of features being continuously added to this application. And the reason why they were wanting to do this migration is because you can see here, actually, let's just zoom into this part. We're like, this is the last version of .NET 4 right here, which was 2019. So that's it. There's no more no more of those being released. And at the time, Microsoft said like, we'll give it 5 years of support and then it's end of life. And then like 5 years go by and they're like, aha, just kidding, we're gonna support it forever. So technically this client could have stayed on that framework forever, I guess. But they started to notice a problem where like none of the packages, none of the dependencies, none of the control libraries they were depending on were being updated anymore. So like, well, if we wanted to ensure that this application can keep going forward in the future, we need to jump ship, get off of .NET Framework and onto, at the time it was gonna be .NET 6 and eventually it was .NET 8. So during this time period, you could see like .NET Core and .NET Framework were still getting released and being developed at the same time, but at some point, Microsoft had to decide like, we're gonna just put all our eggs in this basket and just go to .NET Core, now it's just .NET 5, 6, 7, and 8. This is an application that, again, had been continuously developed for over 10 years, which means that there is a lot of things going on in the application. So me as a consultant, the first thing we get asked is like, well, yes, we want to upgrade, but how much is it going to cost? So I have to understand, like, well, what is the relative size and scope of the thing we're trying to achieve here, and how big is the application, and how much work is it going to take to actually to migrate it over? And there's a few different ways I do this. I like to get just kind of a catalog of everything the application does, as well as like all the dependencies it's using, any kind of libraries, things like that, just to understand, are these things, what's the migration path for each of these different items? So I'm looking for things like all the MVC endpoints. So these are like MVC and API controllers and actions. I'm also looking for all the non-MVC HTTP endpoints. And this is one of those ones like I forgot that all these things even existed. So there's things like ASHX files that can just can handle requests. And I just like put these all out of my mind, but looking at a legacy application, like, okay, the pain comes rushing back of all these things that are now gone. So those still need to be migrated as well somehow. We're also looking at any kind of middleware that we have going on in the application. So what are the kind of extension points the developers have put into the MVC application over time? Also looking at any like regular ASP.NET middleware, so all the web config junk. And then library dependencies, component dependencies. So what are all the things that are outside of the Microsoft set of kind of standard tool is this application using to be able to run its system? Now, I didn't build something this crazy. I just built like a representative application. So this one is tried to match as much as possible the different kinds of things I ran into this system. And I will say like this is a very much like a personal story of how we migrated this application and the dependencies we ran into there. A lot of them are pretty common in applications I've seen in different different clients over the years. But you're definitely going to have some library where you're like, well, how did you handle this dependency? And like, well, if we didn't have to handle it, I didn't care about it. So there'll definitely be some of those in here as well. So this application is just MVC5 with Razor view engine. You know there's another view engine as well? No, web forms view engine. So the very first version of MVC used web forms as the view engine, and luckily this one was not using that one because that would have been a complete disaster. So this is still using Razor as the view engine. It was not a SPA, so it was like still server-side rendered, which I guess is now back in again. Like people are now doing that again, so huzzah. It was using SignalR for like notifications to like, hey, this job has been completed, that sort of thing. Of course, it was using session state. This was in a web farm scenario, so the session state was stored in SQL Server. It used Hangfire, and if you've never used Hangfire, we'll get into a little bit more details than that, but that presented its own kind of special set of problems for us. And in terms of like the application architecture itself, if you kind of rewind time to like 2010, this was that state of the art. So think like Onion architecture, let's see, like, lots of different projects and stuff. Now we call it Clean, but back then it was called Onion. But it was just like, this is the way to do things back in 2010. So I knew that we were gonna have to upgrade every single page in the application. But I needed to understand like how many pages actually exist in here. So instead of having someone like kind of click around and just kind of catalog all the pages, I just wrote a little bit of code that uses, the code doesn't matter, but it's basically using reflection to examine the different controllers and types in the system and spit out just a spreadsheet of like, here are all the different controllers, here are all the different, the number of actions on each of those controllers. And then I'm also just like getting any other kind of statistics to see like, well, how difficult is it for us to migrate this one individual thing? So I may be even looking at things like, what controller action attributes are on there for filters, because maybe if there's more filters, it's harder to migrate, that sort of thing. But really what I'm trying to do is trying to get how big is this application? And then also trying to understand, where should I start? What should be the first one we migrate? And ideally, it's not like the hardest one, but it's also not the most trivial one. We want to pick something that brings in enough kind of stuff for us to kind of prove out this way of us doing this, but not pick like the most complicated thing in here. We also looked at the different kind of MVC features and middleware I was using. There's nothing too interesting here. We do see some like there's some entity framework junk here. So this application was using EF6. And then it's using like some special view engine for whatever reason over here. And then we also had some special filters as part of this. So as we're going through the application, we have to understand, are these things that we actually want to migrate to ASP.NET Core? Are these things that are just out of the box with it? Or is it something, again, I have to write custom code to extend the framework to do whatever it is this middleware junk is? And I also forgot that like back in those days, there wasn't just ASP.NET, ASP.NET MVC. There was this whole OWIN thing, the Open Web Interface for .NET, which again, I just completely had put out of my head, I forgot about. But that has its own individual set of like middleware configuration that vaguely resembles now what we see today of services.app. But this has some stuff there as well. So here we can see that it does have SignalR, it's got Hangfire, the dashboard and the server, and it's doing some configuration for Hangfire there with a SQL backend. So again, these are all things that I'm going to have to build a plan for to migrate over to the new application. In terms of the ASP.NET middleware, this is again like, I just forgot how painful this used to be of like going through the magical XML web config file to see all the kind of custom little doodad things that have been put in over the years and see like, is this even being used today? Is it just junk that someone pasted in 8 years ago, we forgot about, and now it just kind of lives on forever? So here, for example, I see that it's doing nothing too interesting like compilation, runtime, whatever. It does have custom errors on and has a custom error page, which for some reason is web forms. Like, I don't know why the 404 page was a web forms page, but it was back then. And then this library that is dead now, Glimpse, which I still miss. I'm also looking at all the dependencies. Like, this is not an exhaustive list, but just to understand like what other libraries is this thing depending on, and how can we then migrate each of these dependencies up to something that can run on .NET Core. So right when we started this project, we had the question of like, well, how are we actually going to perform this migration? And prior to .NET 6, this kind of migration from .NET 4 something to .NET Core used to be like a huge, huge pain. So in the past, the way we would do this would be to have the new application, which is the .NET Core application, the ASP.NET Core application. We have the existing application, and then we would manually migrate one page at a time from the ASP.NET 5 application to the ASP.NET Core application. And then in order for us to have these little switchovers from the one application to the other, we would put a reverse proxy, like Nginx or something, in front of those two applications, and then manually go into the routing of the Nginx file and say, okay, this sprint, we've migrated these controllers, so go ahead and add those entries into the Nginx file to say now those requests should go over to this application instead. So something that Microsoft released like literally like a month before we started this project, was fantastic, are this poorly named library, but whatever, it's called the system.web adapters. And so this library is, it's a NuGet package, but also includes some Visual Studio extensions, which you don't have to use, but I'll be showing those here in a bit. What this library and some of the tools available for us make it 8,000 times easier, and I've calculated that, 8,000 times easier to migrate from an existing ASP.NET application to an ASP.NET Core application in an incremental fashion. Now, they did also release like an automatic migration tool, but I don't know about you, I don't like staring at 10,000 compile errors as like the end of my migration results. And so they ditched all that and said, you know what, that never works like ever. So instead, the only way they really support doing this is through an incremental migration, which is what we want to do anyway. We don't want a big bang, okay, flip the switch and hope it works. We want something that's very incremental. So this is our application today. We have incoming requests that go to our ASP.NET 5 application, and then it has, that relies on some business logic and database in the back end. So the system.web adapters piece comes in via a new ASP.NET Core application. And so now the requests go straight to that ASP.NET Core application. And the system web adapters, what it does is it includes a reverse proxy in that same application. So this is YARP, yet another reverse proxy, is now hosted inside of the new ASP.NET Core application. And if the ASP.NET Core application cannot handle the requests, it will seamlessly and silently reverse proxy that request over to our .NET Framework application. So just like if the controller doesn't exist over there, it will automatically forward that request over to our existing application. So we do have to deploy this out though, right? We do have to have a new ASP.NET Core application deployed out somewhere, so that is going to be some extra complexity in our kind of deployment pipeline and build and deployment process. But we don't have to include another reverse proxy in front of this. So prior to this tool, I would have to have Nginx somewhere over there. Maybe it was already there, but in any case, I would have to have a reverse proxy in front of all this, and then manually, as new things came online, manually include that configuration to go to the right application. Now, if the ASP.NET Core application can serve that request, it will just serve the request. And if it can't, automatically forward over to the .NET Framework app for any kind of request. So this is like, static files, like actual pages, ASPX, ASA, like anything, if it can't handle that request, gets forwarded over to the .NET Framework application. This also supports SignalR as well. So just like magically, we'll be able to forward the proxy of the SignalR request over to the .NET Framework application if that framework application is the SignalR server. So the other thing that it provides you that we didn't really use that much were also adapters. So you might have a lot of business logic code, hopefully not, that's doing like system.web junk, like HTTP context.something. So those two interfaces are like the HTTP context junk and the ASP.NET Core application is a different, like it's a different type, different class, different namespace, different project, different assembly. It's completely different than the one that exists in the .NET Framework application. So what the adapters do is say, okay, we'll detect where you're running, and if you're running in ASP.NET Core, your system.web HTTP context will forward automatically to the real objects. And if you're over in .NET Framework land, then it'll just use like those objects out of the box. Again, this is only really useful if you have a bunch of code in your business logic doing system.web junk, which hopefully you don't, right? You probably shouldn't have a bunch of system web stuff in your business logic, but in case you do, those adapters are there. So now we just, quote, migrate one at a time individual controllers with all their actions, all their views, over to the ASP.NET Core application. So over time, the ASP.NET Core application becomes bigger and bigger, and the .NET Framework application gets smaller and smaller. Then at some point, there are no more controllers over here. There's no more requests being served, and so this just lives out there on the web server doing absolutely nothing. And so at that point, it's safe for us to then remove this application from everywhere, and then now all of our requests are being served by the ASP.NET Core application. Easier said than done, though. So I want to do a quick demo of the upgrade assistant just to show you what this looks like and the magic behind the scenes. So let me go ahead and switch over to. Let me stop. All right. There we are. Okay, so this is just file new ASP.NET web forms, or not web forms, MVC application, which I hadn't done in forever, but this is it. So you can see we've got all the kind of normal stuff here. We've got a global ASAX file. Again, I forgot about that thing. We've got a web config. We've got just a regular controller. So let me just go run this just to make sure it actually can run. Now I didn't put any kind of other special stuff in here, so this literally is just file new, and that's it. Of course. Oh, oh. Oh my gosh. I should have run this back at the hotel. Oh well, it's fine. Yes, yes, yes. Come on, you can do it. No, Postman, I don't need you. Oh, wow. Web Forms is so bad, it won't even show the application here. All right, well, it's fine. I don't know why it's not working, but whatever. So the important bit, though, is this upgrade process. So what I'll do here is, and again, you don't have to do this via Visual Studio. There's command line tools to do all this, but this just does some of the magic for us. So I right-click this guy, and I say upgrade. This upgrade here comes from the .NET Upgrade Assistant from my extensions here. So if I go to look at my extensions, I can see that I have this one right here, the .NET Upgrade Assistant. That's the one that does the Visual Studio tooling. Again, we don't have to use that, but it makes for a nice demo. So I can right-click this and say upgrade. No, not App Insights. No. Right-click. Come on. Upgrade. There we go. Okay. So there's two options given to us here. One is upgrade project to a newer .NET version, or upgrade the project features. I don't even know what the other one is. This first one is the one we want. We want to upgrade the project to a newer .NET version. What is your upgrade type? There's only one available for us, which is a side-by-side incremental upgrade. Let's go ahead and click Next. And we will create a new project for the ASP.NET Core application. And then finally, it'll ask us what the name of the new project should be for the ASP.NET Core application and the project template, so MVC or Web API. I mean, again, we don't have to like pick one of these things, but it just makes our lives a little bit easier. And then finally it says what's our target framework we want. And we want .NET 8, the latest LTS version. Okay. So it's doing some junk. It's added a new project there for us. It's configuring the project dependencies. So I'll dig into the dependencies here in a minute. And it's done. Okay. So let's take a look and see what happened behind the scenes here. So this project, let me go ahead and bump the font a little bit. Okay, so this is just a normal vanilla ASP.NET Core project. So it's using the Microsoft .NET SDK Web project type, targeting .NET 8 with the C# features, whatever. And really the only thing that's added are these two project references, the System Web Adapters Core Services, and then YARP. So YARP is the magic that's doing the reverse proxy for us. And the actual code itself, most of it looks pretty normal for an ASP.NET Core application, except for we've got a couple additional things here for adding system web adapters. These are the adapters for system.web stuff. And then also adding the HTTP forwarder. So this is configuring that reverse proxy to be able to, if I can't handle this response successfully, go ahead and forward that over to the ASP.NET application. Normal junk, normal junk, normal junk, normal junk, normal junk. And then finally down here, we say use system web adapters. Now the order of this is important because now we're in middleware land. We want the forwarder to be the very last thing that happens. So after we map the default controller route and any other routing that you're doing, like minimal API junk, whatever, the very, very, very last thing you need to do is map the forwarder. That just says, okay, for everything else, if nothing else is able to handle this request successfully, then you will forward this over on to this proxy2 address, which is proxy2, it's going to be over here, my launch settings. There we are, proxy2 localhost 44331. And so that localhost is the URL for the ASP.NET application. So just a little bit of configuration to say the other application is over here. So in each environment, I'll have to put the right value of that in there. So like, my dev, QA environments, prod, then those values for the forwarding proxy2 address will be different. The other thing that's different here is when I launch this application, or launch this solution, Visual Studio is also configured for both of these applications to run. Where previously it was just the ASP.NET application, now when I hit F5, it's going to be running both of them because both of them have to be up and running for me to successfully be able to handle requests. It is kind of funny because you can just serve requests from the ASP.NET 5 application or the ASP.NET Core, and then you'll have this weird thing that sometimes things don't work, but we'll have both of them up and running here. Okay. So localhost 7023, this is the ASP.NET Core application, except if you look closely here, it's all about ASP.NET, like the previous version. So it is successfully serving those requests from the ASP.NET application. And in my ASP.NET Core application, we can see that there's no controllers or anything in there. So this application is just transparently serving all the requests from the ASP.NET underlying application. So how do we get this thing to now serve its own requests? So one way we can do this, and this is not something we actually did in a project, but again, makes for a nice demo. I can right-click this controller and say upgrade controller. This will almost certainly not work for you, but it's at least nice to see okay, what are the kinds of things we have to worry about when we migrate from one to the other? So let's go ahead and say upgrade. Upgrade selection. So it's what do you want to upgrade? I want to upgrade the controller. And also it will look to see what other types are being used in this as well. So if I have business logic, we'll get into that a little bit. It won't just magically upgrade all that code as well. So typically I'm having to dig into the controller to see what the heck is this thing doing, upgrade all that stuff first, and then come back into the controller itself. But this is saying, okay, we're going to upgrade the default routes, these individual views. We're going to go ahead and upgrade all these things. and it's going to work fantastic, right? We'll see. Is it done? Yes, it's done. Okay. So we can see over here that now we have a home controller. We have our view imports, the view start. We even have our layout pulled in as well. So it was pretty smart to be able to pull in all these different things. So let's launch it and see how it runs. Spoiler, not too great, but whatever. Oh, that looks great, right? Yeah, this is one of those like very disappointing moments like, oh, this is gonna be so easy for the migration. The first page shows up like, oh, not so easy. So what's going on here? None of the static assets loaded. So if I look at the network tab, let me go ahead and refresh this. Well, it didn't even, now let me get all of them. It's not even requesting other things. It's got the fav icon, something with ASP.NET Core and Visual Studio, but like none of the other CSS and stuff showed up here. They're just completely missing. So why is that? Well, let's go look at the code itself to see if there's any clues about why this doesn't look so hot. All right. So first, we'll go ahead and look at the controller. Okay, so it looks, there's no compiler errors or anything like this, so there's nothing really suspicious here. And if I go back to the other controller, we can see what are the exact things that have actually changed as part of this. So it says it's you know, this is the ASP.NET 5 version, so it's a controller inheriting from some base controller class. The other one is the same, but it's a different one, right? It's the Microsoft ASP.NET Core.MVC controller versus this one is the System Web MVC controller, right? So they're different types, different namespaces, different packages, blah, 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 but it looks very, very, very similar. So the controller classes themselves usually are pretty straightforward to upgrade. Like there may be some slight namespace things you have to fix, or if you're doing like really weird things with action results, but for the most part, like this is pretty straightforward here. Okay, what about our views? So let's go look at our view imports first. Okay, so this looks, I don't know, looks okay. There's nothing out of the ordinary here. View starts just gives me a layout. That's what we saw over here as well. There's the layout. All right, so let's go ahead and look at our home index page. And this looks just like normal HTML. There's not even like any tag helpers or anything like that here. So this is all well and good. And finally, let's look at our layout. Wah, wah. So this is our first big hurdle that we ran into, that ASP.NET Core does not have any out-of-the-box support for bundling or minification, which, I mean, I guess is a good thing because that's like a solved problem now. However, our application, our ASP.NET 5 application was happily using the heck out of bundling and minification. And so we can see here, like, it can't do that. That is not a feature that exists or will ever exist in ASP.NET Core. So why don't we see nice styling? It's not even rendering the styling whatsoever. So sad trombone. We have to fix all of these different like script blocks and styles, and all this bundling and minification just does not exist in ASP.NET Core. All right, so the highlight, oh, there's one thing I wanted to show, one last thing, sorry. Back in my ASP.NET 4.5 application, I wanted to show what things were changed there. So one of the things that was added were some additional packages for this web infrastructure stuff. And in our global ASAX, we don't even have that yet. So actually nothing was changed here. It's just as it was before. That will change shortly though here. Okay, so the upgrade assistant is nice for that very first step of the like right-click upgrade, and it creates the ASP.NET Core project with the right package references. But you don't have to use it, right? It's just a couple NuGet packages and some configuration in my middleware to be able to serve those requests now. Not that big of a deal. So our very first step when we were doing this migration, the very first thing we wanted to do was just get an empty application that does absolutely nothing, like it doesn't serve any requests, all the way out to production. So this one was really just doing that migration assistant We right-clicked and said upgrade, and we wanted to make sure that we can get that all the way out to production. So this meant we had to go, at this point, this application was still being served on-prem and IIS. So we had to go, install the right ASP.NET Core hosting packages on the web servers, on the web farm. We had to configure IIS for this new web application. We had to migrate or modify all of our build and deploy pipelines to now build and deploy this new ASP.NET Core application and make sure that worked all the way out from local debugging all the way out to production. But this application would do absolutely nothing. So we're just trying to reduce the amount of risk of all these different steps to say, let's just make sure we can serve requests, and then all we did was just log. Make sure we're logging the requests that we're actually serving requests from this application. But otherwise, it did nothing except forward every single request over to the ASP.NET application. Now this is where usually these folks are asking what about performance? Because now I have an extra network hop, or at least an extra application hop, where all requests now go to this ASP.NET Core application, and then we'll then serve the request to the ASP.NET application. So there's going to be some overhead with that. But for my clients, they're all enterprise-y folks, right? They're not building big public websites. These are applications with the users in the thousands, not with the millions. Still important applications for their customers, but their customers aren't that necessarily performance-minded in the first place. And a lot of these pages were making 1,000 SQL queries anyway, so I'm what's a little more latency on top of that? No big deal. But anyway, in our testing, it was fairly minimal latency being added because both of these applications were still being hosted on the same server, so we did not have to do an extra network hop. It was still just going to localhost for all these, so it was 50 milliseconds maybe for each request that we added on top of it. But each request was already taking 2 seconds, so we're what's another 50 milliseconds? Whatever. All right, so the next step we need to do is figure out what to do with all of our business logic. And so for that, we'll need to create a shared library that will house all this shared code between the ASP.NET 4.5 MVC5 application and the ASP.NET Core 8 application. We're not going to share any of the UI logic. Those are all just copy paste, we're gonna duplicate it, whatever. But for all the business logic and things like your EF core or EF models, all that other junk, we do wanna have share between these two. Most folks I know would already have a library that is being used by their ASP.NET MVC5 application. They just have a core or a domain or something like that. But pretending we don't, we'll need to move all of that shared code out into some common location that both of these applications can then reference and use. So what are the things we want to share between these two different applications? Again, none of the UI logic, that's just going to be copied and pasted. There's no common libraries between ASP.NET Core and ASP.NET MVC5. So any kind of customizations there are just going to have to be duplicated or maybe even just left behind. The things we do want to share is really when we look inside any of our controller actions, if we kind of remove all of the UI junk, we really want to just do the business logic. And so this application delegates all business logic to these handler classes. And so these are the things that I want to migrate over into that shared library. So all of our data models, those are going to be shared across different requests, old and new. So your EF models or EF core, well, probably EF6 at this point. Whatever those common data objects are, we'll want to move those over. Any kind of business logic as well, so services, helpers, factories, all that other junk that's not touching any kind of system.web namespace, we'll want to move into this common location. And any other non-UI code we'll want to put in this common location. Now, I don't necessarily migrate everything all at once. Typically what I'm doing is looking at individual controllers, looking inside of the controllers, saying what are these controllers doing, and then any kind of code that is still living in that MVC5 project, okay, then I'll move that over to the common location. But again, I'm trying not to just have these really big migrations, these really big efforts, trying to be very incremental in my steps. Now, ideally, our target framework for that shared library is .NET Standard 2.0. Because that is the common interfaces that both 4.8 and .NET 8 can talk to. But that's not always the case. We have definitely run into situations where there's something special over on the .NET 4.8 side that is not supported on the .NET 8 side, Or there may be libraries that just don't support these two frameworks, period. And so we might have to multi-target, which really just means I'm building the assembly twice, one for .NET 4.8 and one for .NET 8. And then the logic is the same, but it'll be like really like two different, it'll be two completely different assemblies built for those two different target frameworks. There was this other painful step we had to do, which was looking at all of the dependencies the application was using and trying to understand, do those dependencies support .NET Core or .NET Standard? And if they didn't, then the first thing we need to do is then migrate them over to the latest version that would support, or at least the earliest version that would support those two frameworks. So some things we had to migrate like many versions. Some things were like Entity Framework is a good example. So Entity Framework, starting with I think version 6.4, now supports .NET Core. So just a heads up, if you didn't know that, you don't have to replace all of your data access code if you're using EF6. And we want to treat this as a completely separate exercise of trying to do that migration and just saying, let's just upgrade our library dependencies and go from there. So there were some dependencies where like, this shouldn't even be there in the first place. Like we had Hibernate still there. Like at some point they migrated from Hibernate to an Entity Framework, but they forgot to remove the package reference. So some things we just saw like, oh, we don't even need that anymore. So let's just kill it and not use it at all. So the final result is some core application that includes all like non-UI dependencies, and ideally all of these dependencies support .NET Standard 2.0, but if they don't, they can at least multi-target between different ones. So this was quite a big first step as well, because some of these dependencies didn't support these two frameworks. And so we had to like open pull requests with their maintainers to say, hey, can you support these two libraries? Some things I had foolishly, like Mediator, for example, I decided I didn't want to support .NET Standard anymore, and so I dropped it. And then I needed it, so I'm like, well, I guess it's back again. So we'll just have to have this decision on each of these libraries of do we want to keep it or not, and if so, is there a migration path to .NET Core for each one of these? Now that we've gotten the kind of guts of the controller, the next thing we need to do is figure out like what is the very first controller that we want to pick. And I kind of think of this like as like Mount Everest sort of affair, that we don't want to pick the most challenging controller as the very first thing. Some people see Everest as like a challenge to overcome versus like there being hundreds of dead bodies on that mountain of people that have tried and failed. And so we don't want to be that. We like, how about we just get to like base camp and then like call it a day? Don't try to make the entire summit in one single go, and don't pick the most complicated, most difficult one out there. So we already saw that we can't do the upgrade wizard to do our controller migration. And so the way it's going to work is I will look at the controller and then just copy and paste it and see what the compilers are, just of the controller by itself. And so the very first thing I typically run into are my dependencies, like the things that are getting injected in. So right out of the gates, now I have to figure out, okay, well, how do I now do dependency injection in ASP.NET Core? Do I do exactly what I was doing before, or is there a better way? So ASP.NET Core does support dependency injection out of the box, whereas in ASP.NET MVC 5 it didn't, and there was all these crazy hoops you had to jump through. And so for this one, we looked at, well, how is the existing application doing dependency injection? In this case, it was using a third-party library. It's called structure map. That's not important. But it was using a library to be able to configure and do all the dependency injection. So DI is like kind of there in MVC Classic, the old version, but will almost certainly require some kind of migration. You're not going to be able to just take the exact kind of configuration you had before and then dump it in ASP.NET Core and just assume it was going to work. So this is code that like I wouldn't share. Like it's not worth you trying to share your DI registration code. So we threw it all away and said, can we just, quote, use the existing DI container? But that may not be possible, and it wasn't for us either. We tried to use like the regular like services dot register, singleton, register, transient, whatever. But there was enough customization we were doing in here that we didn't want to unwind, that we said, fine, whatever. We'll just like do the new way of doing whatever this is. And so we wound up using another library by the same author that is still looks almost exactly the same, but there would be some subtle differences. One good example are things like oh gosh, this was like all sorts of junk we really didn't need, but we had things like, oh, a validator factory, controller factory we don't need anymore. There's like the DB context, we had to do all this custom junk to make the lifecycle for DB context being once per request. But now there's a better way of doing that. You can just say dot scoped. And so every scoped web request will get a single DB context. So we use this, like, we pulled over the code and said, okay, is there a better way for doing all of these different things, but not try to make too many changes of the code underneath the covers. Oh, so this was the next like kind of punch to the gut of our view migration. We're like, oh, right, it doesn't support bundling and minification. That really sucks. So in the MVC5 application, it was doing this all this bundling and minification configuration where it's like different jQuery versions. It would handle cache busting and all that junk for us, and it was able to handle like multiple different libraries, bundling them together, having them separated out as well, in case different pages use different stuff, and bundled and minified our CSS as well. So coming to ASP.NET Core, where there doesn't exist an out-of-the-box bundling and minification solution, we're like, well, we don't want to not do that anymore. Like, we still want to bundle and minify our static assets, but what's possible for us here? So there is an OSS library called Web Optimizer from some folks on the ASP.NET Core team that is like a modern-ish version of the bundling and minification of ASP.NET MVC5. So it has a very similar look and feel to MVC5's bundling and minifications, but it's not exactly the same. Like, they didn't keep the same APIs, the same configuration options. So it's different enough where it is like really a new kind of bundling and minification. So even the URLs changed as well. So another kind of like, okay, so each page really does have to know, like, it can't just have the static assets served from one server to the other because those URLs are going to change in the applications. So that's one option, just like find a tool that supports the same pipeline we had before, or like we could adopt a new tool. So this is to get kind of the industry standard tooling for this, like Webpack or whatever people are using these days. I don't keep up with that stuff. So use like an established tool to do so. And this is why like Microsoft doesn't do their own bundling and minification anymore, because they say this is the quote solved problem by other folks, but we were still using the old solved problem way of doing things. And so for this we looked at, well, okay, this is the way to do it correctly, but this is going to require extensive changes to our application, the build pipeline, deployments, all packaging. Is going to be a huge change for us to move to something else from what we have today. So we wound up going with the Web Optimizer routes, and it says use Web Optimizer. Pretty straightforward for us to use. We just had to kind of like do a very similar-ish sort of configuration between the two applications. But that meant that we now have two bundling and minification pipelines, the Web Optimizer one and the MVC5 one. And so we wanted to make sure that if a request is served by ASP.NET Core 8, that it gets the ASP.NET Core 8 bundling minification thing. And if it's not using it, if it's an MVC5 application, then it needs to use the MVC5 bundle. Technically, we could have made all of the requests for the bundles like to stay over here, but we also knew we're going to have to migrate these assets at some point, and we wanted to avoid, again, any kind of big bang into the project. Okay, now it's time to migrate all of our static assets over. We wanted to have it, as we migrate each individual page, we're also migrating all the static assets for that page over to ASP.NET Core. So in this one, the legacy requests use the legacy pipeline. The .NET A requests use the new pipeline. And then we also wanted to make sure that the static assets are shared. So I don't want to copy and paste, JavaScript code between two projects. We wanted to make sure that that code was shared as well. So I said we're not going to share any UI assets, the UI code. Well, that's server-side UI code. We're not going to share that. We are going to share all of our client-side code. So we didn't want to duplicate and have to remember to edit two files. So the way we avoided this, there's this feature in ASP.NET, in Visual Studio projects where you can add files as links. So it doesn't the file doesn't exist on disk. It's like a shortcut to the file that's over there. It's like a symlink sort of thing. And so I just say, go ahead and just pull in all the files in those content folders, and now they just kind of show up magically over here in the right folder in the ASP.NET Core application. So again, that does mean that these are in two like they're served with different URLs, but they're also bundled and minified differently anyway. So we wanted those to be two different things. Okay, so the way this would typically work is I copy over the controller, correcting any namespaces that are being used as part of that, which is usually just like system.web to Microsoft ASP.NET Core.MVC, whatever. So it's pretty straightforward, any of those things, and just correct all of the different compile errors there. And then the controller is going to be calling out to some kind of business logic. So we're going to move that business logic over to the common location if it doesn't already exist there. And that also may require us to pull any additional packages that code is using. And then also we make sure at the end that the controller still compiles with all of this. The final step for any one typical slice is then to copy any of the views over. So any of the pages that use views, I'll pull those views over, and then there could be cases where those views are using custom logic for the UI stuff. So one good example is that we were like, I don't know why, we were really into custom HTML helper extensions at that point in time. Learned my lesson on that, but whatever, that code was there. So any of the kind of common shared UI or the UI custom code, that could not be migrated over. It would be copy and paste and then fix a bunch of compile errors, and then hopefully the behavior is still there. But there are some cases where those different features didn't exist, and so we might have to reinvent how we perform some task in the UI there. And the final step with any one of our controllers was to delete the ASP.NET MVC code. Now the reason why we did this is a whole debate of should we delete the code as we migrate, or should we keep it there so we can still see how it used to work? The problem is, we ran into this after keeping the code, is that the YARP proxy, that final step in the process that forwards requests over, will forward any request over if it is a non-success return value, which doesn't just mean 400 errors, but also could mean 500 errors. So if my ASP.NET Core application throws an exception, the YARP proxy will silently forward the request over to the ASP.NET MVC5 application. So there were a few times where we migrated controllers, we ran the application wow, it looks great, ship it. And then look at the logs and realize, oh, we're getting exceptions, and it was just serving the old application. So that final step was just our gut check to say, let's just make sure it won't serve the request anymore from the old application. So you can delete it, or maybe you rename it, or make the class private, whatever. But we wanted to ensure that the old application would not serve those requests successfully. All right, our next big hurdle was session. Ugh. So session is a special set of shared states on the server side for individual users. Now maybe your application is using a lot of session, but almost everyone here is probably using session at some place in their application. It's just, you want to cache something for a specific user, maybe it's their roles or permissions or whatever, so you're caching it and storing it in a session state. But the problem is that session state is only really accessible from the MVC5 application. So in our web farm scenario, the session state was in a shared database, but the format of the database is not compatible with ASP.NET Core. So it wasn't like I can say, oh, we got a single database that has our session, why can't we just make ASP.NET Core session also point to that same table and then everything will magically work? Well, ASP.NET Core does support SQL, but it looks completely different, because why not? Just change everything, whatever. So we can't just have, quote, just these two applications share the same session store. Instead, we have to have some way of the ASP.NET application exposing its session state to the ASP.NET Core application. So how does this work? So whenever the ASP.NET Core application, and I'm gonna make it simple, but it's much more complicated underneath the covers. If ASP.NET Core needs session, one, it needs to kind of opt into that to say, I need remote session from over there. And the ASP.NET application will now expose an API endpoint for reading and writing session values. So at each request, the ASP.NET Core application will get the current session state from the ASP.NET application. The ASP.NET application will go ahead and get all of its state out, and then the ASP.NET application will then return the session as a JSON object back to the ASP.NET Core application. And now, when I'm inside my ASP.NET Core application, I can read from session, but it's really just reading an in-memory version of what it's already retrieved from the other side here. It also supports updates as well. So if I make changes to session state, the ASP.NET, this adapter will keep track of those changes and push those changes out to the ASP.NET application. Now, this is like, you could have like some concurrency problems, right? Like, what if I have 2 requests trying to alter session state? But the possibility of that is pretty low because it's, again, one user. So does one user have 2 tabs open going back and forth and altering session state? Probably not, but it's something to keep in mind that this does not guarantee consistency like across both applications. It just can't. So the way we configure this on the ASP.NET MVC5 side is in our global.asax, we will say add system web adapters, add the JSON session serializer, and we have to register all the different session values and their types with the session serializer. So ASP.NET Core Session, or ASP.NET Session, I think uses like some weird wonky binary serializer to store session states. Like you can just throw any object in there and it'll just like magically serialize it. ASP.NET Core does not do that. They realize it's a horrible idea to do binary serialization, and instead it uses JSON. So that means for us though that we will have to make sure that all of our session values are serializable to JSON, and we have to register each of those keys and types explicitly here. We'll also expose the remote app server and then provide an API key. So this is like just some GUID or whatever, so that when my ASP.NET Core application makes those requests to the ASP.NET MVC5 application, it will authenticate via this API key. So it's secure. On the ASP.NET Core side, it's a very similar kind of thing, where we say add the JSON session serializer, again registering the keys and the types. And then now we add the remote app client, saying that the remote app URL, this is what it was before, and we had this API key here. And then finally we add the session client. Now using the session is a little funny. There's a couple different options here. The 2 session objects are really quite different from each other, with different options available for how it can treat the different session objects and different persistence objects, all that sort of stuff. So the options they give to us, one, it can wrap an ASP.NET Core session. So when I call ASP.NET Core session, it's actually going to call out to this other one instead. So this is good in cases if I have business logic code that is using session state and I want to be able to migrate it to be able to use either application. So this is okay in cases for that kind of migration sort of option. Our session usage was typically in like action filters and middleware. It wasn't just like sprinkled out through our code. So that kind of migration wasn't really that important to us. Or we explicitly call the remote app for session state with a second option. So this is one way of doing the session. There's a few different ways possible here. You have to opt into it though, to say these explicit controllers and actions should have this remote session state. And the reason why we want to opt into that is because when you get that request, when ASP.NET Core gets that request, and it sees that this request requires remote session, then it's going to call out to the ASP.NET MVC5 application to get all that session details and pull it back in. I don't want that happening on every request if I don't need to, so I can opt into this sort of behavior with, there's the session attribute, or you can just like manually create the session manager and then get the values out like this. So this right here is not calling out to ASP.NET MVC5. Right here in this create async is when it does make that request and grab all the values. Yes, so hopefully you're not using a lot of session, but it is possible to still like have some sort of shared session state, but it is very much a kind of manual process to go into your code and then now call into the other way of doing it. Our next thing we hit was Hangfire. So what is Hangfire? Hangfire is a job scheduling and queuing extension to ASP.NET and ASP.NET Core. So it supports ASP.NET 4X and ASP.NET Core. So it's it runs in the background of an ASP.NET application to do background jobs, queuing, cron style jobs, that sort of thing. So a lot of my systems use this where we don't want to have like some other application to do background tasks. We piggyback on top of the web application to do this sort of stuff. It supports job persistence, so it can store the job details in multiple different kinds of databases, and also supports multiple queues. Could be the queues could be like Azure Service Bus, Azure Storage queues. It could be SQL database-backed queues, but it can persist that data, and that persistence is cross-platform as well. The other thing we wanted to avoid, though, is that we wanted to not duplicate work. So if I kick off a job, I don't want the job to be executed by both hosts. I really want it to be just executed once. Now, Hangfire does support this competing consumer pattern to make sure the job only executes in one place, but the job itself could be anything. So that anything may not even live or exist in the other application whatsoever. So here's an example of this. This is a completely trivial example, but it's pretty typical for how I saw Hangfire being used in this application. So it would be doing some business logic, and then there's something it needs to fire off in the background, like maybe send an email, call an API, call it to Twilio, I don't know, whatever. So it doesn't want to do that in this request, so it in-queues a background job to do the work. But the way that Hangfire does this is kind of magical, because you can see here it's just a lambda expression to the code to call. This code over here executes in the background sometime in the future, but Hangfire makes it super easy just to say execute this method some other time in the future, not in the context of this web request. But this code is living inside of this controller, so if I migrated this controller, it won't know where this job exists anymore. It's just using reflection to say this method, call this method on this object, and do this job. So how we handle this is we split our queues between the ASP.NET Core application and the ASP.NET MVC5 application. So the ASP.NET Core application would have a default -core queue. So if .NET 8 initiated and the job existed on .NET 8, it would use the default core queue. But if the job existed on the other side, and the MVC5 application, then we'd use just the default queue. So that means that Hangfire host on this side would then pick that item up and execute the job. On the reverse side, we can handle that as well. So MVC5 could in-queue a default core job, because we knew the job existed over there. And of course, if I'm just completely in the MVC5 world, we could do that. So we just had to make sure we knew where the job existed to make sure that the right application picked it up and ran with it. This is pretty straightforward to do in Hangfire. When we start up the Hangfire middleware, we tell it the queue that you should listen for. And so that queue we called default or default core, and each host would just listen to its own individual queue. And when I wanted to in-queue a job, I would tell it what queue should you in-queue that job for whatever it was trying to do. So you can do this here directly in the call to the background job clients, or you can also use attributes. There's 20 different ways you can do this, but we did have to make modifications to our code to make sure that the job went to the right location. All right, now comes the really fun part, authentication. Okay, so this is highly, highly dependent on your application, because every single application will do authentication differently. There's no just one way people do authentication. So you can do things like share cookie auth. So if you're doing cookie authentication, then you can have both applications share the same data protection certificates and be able to decrypt those cookies on both sides. We can do that. So this is effectively single sign-on at this point, right? So if you're in a web farm scenario, you're probably already doing this anyway. So we can configure the ASP.NET Core application to also handle this as well. That means we can also sign in or out with either application. The other option is to do remote authentication. This is similar to shared session, in which you're only authenticating against the old application, and then there will be requests made from the MVC Core application to the MVC5 application to get the authentication details and fill out the identity and claims and all that sort of junk. So on the ASP.NET side, we add this additional option for add authentication server, which will expose API endpoints to get the authentication details. And on the client side, we'll do a similar thing where we say add authentication clients, and then finally, of course, use authentication and use authorization. So the ASP.NET Core application is still authenticating each request, but it just can't sign in users. It's going to make a call out to the ASP.NET MVC5 application to get all the identity details and all the claims. All right, so as we went through here, migrating each of these different options, we would look at, okay, for each set of code, outside of the kind of controller action view sort of stuff, we would evaluate to say, like, does each of this item actually need to be migrated at all? And there were some cases, like when we went to middleware, we didn't need to migrate any of that stuff because it was all now built into the ASP.NET Core. But we just, over time, migrated one controller and action at a time until eventually we were left with nothing. And so this was the final step of turning off the lights and locking up before we left. So this last step was we would enable the session on ASP.NET Core and disable it on ASP.NET 5. So now session now existed solely on the ASP.NET Core side. We removed all remaining controllers and HTTP endpoints from MVC 5. We disabled the remote authentication and session, the remote clients in ASP.NET Core, so it was only doing it inside the ASP.NET Core application. Removed any other additional shims for bridging over to MVC 5, so any kind of like, if ASP.NET Core do this, otherwise do this, we removed all those as well. And finally, we would deploy this out and monitor the MVC 5 application for any traffic. We did this for like a week or so to say, like, make sure that we're still not getting any requests to that MVC 5 application. And then finally, once we knew like there's nothing else going on there, remove the MVC 5 application from code, pipelines, deployments, and pop the champagne bottle because no more ASP.NET MVC 5. So just some parting thoughts here. The incremental migration process that I described today, that's the one that will minimize the risk of a big bang deployment by having very small verifiable deployments. So we were deploying multiple times a week. Every time we would finish a controller, it was getting deployed out to production and tested. Except for web forms. There's no incremental migration with web forms. You are screwed. You have to do a complete rewrite of every single one of those pages. There is no migration path for you. But if you still have not migrated web forms in the year 2024, that's your own fault, I guess. Or maybe whoever does the budget's their fault. These system web adapters are what enable that incremental migration with the magic of the YARP reverse proxy. But there will always be something that is like unique to your application and system. I've definitely not covered every single possibility here. So there will be something that you run into that you'll have to deal with and overcome, but it is overcomable. The last thing is we really try to avoid any like quote improvements to the architecture because we're going in and changing code. We're like, oh, we can go to this new way of doing things. And so we really had to put a kibosh on all those kind of things to say, this is a straight lift and shift of the MVC 5 application to ASP.NET Core, and as much as possible, avoid any other kind of like, quote, improvements over time. So thank you all very much. If you want to hear more about this, you can come grab me after this. Otherwise, I hope you'll have a great rest of the conference. Thank you.